In this video, we're going to look at factoring trinomials, and we're going to look at some of the easiest of the trinomials to factor. And I say easy because you'll notice that the lead coefficient is 1. And as long as the lead coefficient is 1, this is a fairly simple problem for us to factor. All we need to do is look at the constant term, find factors of the constant. You want those factors to add to 14. Now, again, when I do this, when you see me factor like this, I'm ignoring the signs for right now, except for the plus. So I need to find factors of 40 that add to 14. Now, if you can't think of those right off the top of your head, go off to the side and make a list of all the factor pairs of 40, starting with 1 times 40. Now, those guys don't add to 14, so we keep going. 2 goes into 40 20 times. 3 does not go into 40. At least not evenly. 4 goes in 10 times, and 5 goes into 40 8 times. So we're looking for that combination that's going to multiply to 40, so one of these guys right here, and adds to 14, and that's the 4 and the 10 right here. And as long as we can find a combination that works, the 4 and the 10 will be the numbers that go inside the factored form. So x squared is going to break down as x times x, and the 40 is going to break down according to these two numbers right here, 4 and 10. Now the rest of this comes down to being able to play with your signs. We have to multiply to get a positive 40, so that means they have to have the same sign, either two positive numbers or two negative numbers. Now, since this middle term is positive, that means that both of these guys must be positive, like that. And it's a pretty simple exercise to check to make sure that this does work. Of course, x times x gives you x squared. Positive 4 times positive 10 is positive 40. And when you check inside and outside of the FOIL method, this gives you a plus 4x. And on the outside, x times 10 is positive 10x, which gives you positive 14x when you finish combining those guys. So everything checks out. Then we go on to this one. Here we are looking for factors of 30. Factors of 30 that add to 11. And as I mentioned before, go off to the side and list all of the factor pairs for that constant. Now you might say, I already know the answer. Great. But you want to get in the habit of being able to list off all of those factor pairs for that one occasion where it's not the first one that comes to your mind. So, the factors of 30, you've got 1 and 30, make a nice pair. 2 and 15, those guys don't add to 11. 3 and 10, those add to 13, but we're getting closer. 4 does not go into 30 evenly, and then we arrive at 5 times 6. And 5 and 6 is that perfect pair that will multiply to give you 60, and 5 and 6 will add to give you 11. So when we factor this, using those two famous sets of parentheses, we break down x squared as x and x. We know that 30 is going to break down as 5 times 6. Now, as we mentioned before, if you have to get a positive number here at the constant, both of these signs have to be both positive or both negative. Look at the sign of the middle term. You have to be able to combine numbers to get a negative middle term, which means both of these guys will be negative. So that when you multiply things out, on the inside you get a negative 5x, and on the outside of the FOIL process, you get negative 6x. And when these combine, we get negative 11x. So everything checks out. You know, just for good measure, let's box this. Somehow that makes us all feel better about our answers, right? There we go. All right, let's look at another one. X squared plus 4xy minus 12y squared. Now, this is not a standard trinomial. When I say standard, I mean something that goes x squared, x, and then the constant. Instead, it's a little bit different because we've got the y's here. But I want you to think about it this way. If I were to try to factor this, and you already have an idea about x squared, how this guy should break down as x times x, then I bet that with the y squared here, I should probably break that y squared component down the same way that I did for x squared. So I think we should probably do y times y to get the y squared. And then we can go back and play the number game. Find those factors of 12 in this case. And I want those factors of 12 to subtract to get 4. And the factors of 12 that subtract to 4 would be 6 and 2. So I'm going to break down 12y squared to be 6y and 2y. So when you multiply these two pieces right here, there you get your 12. Y times y is y squared. But you got to pay attention to your signs. In order for us to get a negative 12 when we multiply, that means you have to have one positive and one negative number. So a lot of students will ask, well, how do I know which one is which? Well, look at this. You have to end up with a positive, which means when you take a positive and a negative and you combine them, the positive number has to win out. It's got to be the larger of the two in terms of absolute value. So that means we need to have a positive 6y and a negative 2y. Watch your signs. Positive 6 times negative 2 gives you the negative 12. When you check inside and outside, watch what happens. On the inside, you get a positive 6xy. On the outside of the product, x times negative 2y is negative 2xy. And when you combine these guys, which are now like terms, you get a positive 4xy, which is exactly what I was supposed to have. We already know that's x squared, and we already confirmed that that's negative 12y squared. So another problem easily knocked out. Okay, and let's do one last problem. This is x to the third minus 7y squared minus 78x. Anytime it comes to factoring, you always want to look for the greatest common factor. See if there's something that all terms in the polynomial have in common. Well, if I look at these three terms, they all contain x. So that means that right away I can factor x out of this polynomial. Now, that doesn't mean that the x disappears. You write that common factor out in front. So this now becomes x squared minus 7x and then minus 78. It did have an x, but we factored that out as a common factor. And so now, this is just a normal looking trinomial. This has a lead coefficient of 1, so we look at the constant. Find factors of that constant that have a difference of 7. Now this may not be on your radar, so let's go up to the side and try to figure this out. So if I look at 78, well, the obvious guy there is 1 times 78. 2 goes into 78 39 times. Okay, and then after that you might get kind of stuck and not know where you're supposed to go. Here's a little trick for you. If you can factor 78 at all, do a little factor tree off to the side. We've got 2 times 39, and then 39 breaks down as 3 times 13. And now you're kind of stuck because you can't do anything else with the 13. So these factors here make up the prime factorization for 78. So when I go through this process of trying to find all the factor pairs, I can look over here to help me out. So you might say, how do I know if 3 goes into 78? Look at your prime factorization. 3 is right here. And so that's 3, and the other factors, 2 and 13, multiply to give you 26. Those guys don't have a difference of 7, so we've got to move on. Well, how about 4? Well, in order to make 4, you have to have not just a 2, but you have to have another factor of 2, because 2 times 2 is 4. So I don't see that. That means 4 is not going to work. Go to 5. 5 is a prime number, but it's not listed here among the prime factorization. So that guy's gone. Well, what about 6? Can you find 6 here? Well, 2 times 3 is 6. So if I use 2 and 3, that means the other part of that factorization is going to be 13. And you can easily check to see that 6 times 13 is a factorization of 78. If I keep going, you're not going to find anything else that works. 7 is a prime factor, is prime number, but it's not here among the prime factorization. 8 isn't going to work, and I know this from the very beginning because if 4 doesn't work, if 4 is not a factor, that means no other multiple of 4 can work. So 8's gone. I could try 9, but 9 needs 2 factors of 3, so that's gone. I could try 10, but since 10 is a multiple of 5, and 5 didn't work, no multiple of 5 will work. So 10's gone. 11's a prime number that's not listed here, and the next number would be 12, but again 12 is a multiple of 4, so he's gone, and so this is it. After 12 I get to 13, so I'm back up here. So the factors of 78 that have a difference of 7 will be 6 and 13. And we're going to use those numbers to finish this factorization. This is my common factor, so he's still written out in front. I'm going to take this trinomial, split it up into 2 sets of parentheses, using the 6 and the 13. In order to multiply to get a negative 78, I have to have one positive and one negative factor. But to end up with a negative 7 at the end, that tells me that the larger of those two factors must be the negative one. Because when you combine those guys, the negative has to win out, which means his absolute value must be larger. And so here is a complete factorization of that polynomial. You take out the greatest common factor first, and then you factor the trinomial, just like we did in the previous problems.